Welcome to JD's Prep. In this question, we're looking at some data of several simulated surveys where we have a mean of 43%, or in this case, our decimal of 0.43. And we're trying to find the standard deviation of the simulation. In order to figure this out, we need to be familiar with the idea that 95%, when we're looking at a standard normal distribution, 95% of the data lies within two standard deviations of the mean. So when we look at this standard normal distribution here, between the z-scores of -2 and +2, we have 95% of the data. Now, if we wanted to check, for example, if option number 4 makes sense, with a standard deviation of 0.43, that would mean if we take our average of 0.43, and both add and subtract two of those standard deviations. Let's start just by adding it. Two standard deviations. We get 1.29, which is 129%. So obviously that's way off the charts and not possible. If we were to check that with 0.09, so we take that the mean and add two of that standard deviation, we get 0.61. And you can see that's actually also way too much. In fact, that would be 100% of the data would be within that range. So that also doesn't make sense. If we check the second option, actually, let's jump to option number 1, 0.02. If we take our mean and add 2 of that standard deviation, we get 0.47, which sounds like much more reasonable. And if we were to subtract 2 multiplied by 0.02, we get a lower range of 0.39. So let's take a look at the data and see if that makes sense. So 0.39 right around here, and 0.47 right around here. Does that make sense to you? Hopefully not. In fact, if that looks like more like half of all the data is within that range, not 95%. So option number 2 is definitely our correct answer. And if we do calculate the mean of 0.43 plus or minus 2 of 0.05, you end up getting a z-score of -2 of 0.33. And then the z-score at 2 being 0.53. And that's looking much more accurate to be 95% of the data. All right, that's it for this video, and thanks for using JD's Prep.